In section 1.7, we will write the equation of the line. The goals of this lesson are to write the equation of a line in point-slope form given a point and the slope. Also to find the slope of a line parallel or perpendicular to a given line, to write the equation of a line parallel to a given line, and to write the equation of a line perpendicular to a given line. As we talk about writing the equation of the line, we need to review point-slope form. Point-slope form reads y minus y sub 1 equals m times the quantity x minus x sub 1, where m represents the slope and x1 comma y1 represents a point on the line. So given the slope and a point on the line, we want to write the equation of the line in point-slope form. So as we do this, we're filling in y minus our y value here. So that's going to be y minus 3 is equal to the slope, which is 2, times the quantity, and it's x minus our x value. Now what happens here, again, I said y minus our y value of 3 is equal to m times the quantity. X minus a negative 1 is going to turn this into x plus 1. And this ends up being the equation. So we do the same thing for number 2. Here I'll have y minus a negative 5, which really becomes y plus 5, is equal to negative 4 times the quantity x minus 0. Now for x minus 0, we could keep that as x minus 0, but we could also just write that as x. And in fact, I don't even really need the parentheses here. I could have just written as y plus 5 is equal to negative 4x. In each of these cases, what you want to notice is that the signs are switching. So if it's negative here, it's going to be positive here. This was positive here. It shows up as negative here. The 0, we don't have a positive or negative 0, so that one is a little bit of a different situation. That just stays a 0, but that negative 5 turned into a positive 5. However, we are leaving the slope the same in each of these situations. Now, when we talk about parallel and perpendicular lines, we want to remember that parallel lines have the same slope, and that perpendicular lines have opposite reciprocal slopes. So we're going to start by identifying the parallel and perpendicular slopes of each of the lines below. In example 1, we start by subtracting 2x on each side. That will end up giving us negative 7y is equal to negative 2x plus 12. From there, we divide everything through by negative 7, which is going to make this negative 2 divided by negative 7 gives us positive 2 sevenths x. 12 divided by negative 7 will make this minus 12 sevenths. Therefore, the parallel slope is going to be the same. It's going to stay 2 sevenths, and then the perpendicular slope, when we do the opposite reciprocal, should be negative 7 over 2. For number 2, start this the same way. We solve for y. So if I add x to each side, I get 3y is equal to x plus 10. Then I divide everything through by 3, giving me y is equal to 1/3 x plus 10/3. Again, the 10/3 is irrelevant in this situation. What we're looking at is to find the parallel slope. We identify the original slope as 1/3. The parallel slope will be the same. Then the perpendicular slope is going to be the opposite sign, so this will be negative, and then we're going to flip 1/3 to give us 3 over 1, and a better way to write that is just 3. So the perpendicular slope there would be negative 3. Now when we talk about finding the equation of a parallel line, we're going to use the points that's given and the equation of the line provided to determine the point-slope form of the parallel line. We need to be able to write equations of lines in many different forms. So for example 1, we see that the slope is going to be 2. We can also see that the point is given at negative 1 comma 5. Coming up with point-slope form, as we did in the previous problems, is just going to be y minus our y value, so y minus 5 is equal to m, which is 2 times the quantity x plus 1. Now from there, when we want to write in standard form and slope-intercept form, the easiest one to move into next is going to be slope-intercept form. So I'm going to take this line right here and just solve this for y. And my work is going to be written over here. So I'm taking the equation that we just got, and I'm going to start by distributing the 2 in, which gives me y minus 5 equals 2x plus 2. From here to get y by itself, I just have to add the 5 over, and that gives me y is equal to 2x plus 7. Then finally, to come up with standard form, for standard form, I need the x and y to both be on the left side, and I also need my lead coefficient to be positive. So I take that problem that we just had, y equals 2x plus 7. I'll start by subtracting 2x, which gives me negative 2x plus y equals 7. Again, that's not in standard form because my a value here, the lead coefficient, should be positive. So I'm going to multiply that through by a negative 1, which then gives me 2x minus y equals negative 7. And those three equations are all of the same line. In the next example, we start the same way. Now this one, they give us the line in slope-intercept form, but we can still identify that the slope is negative 4. From there, the point-slope form of this line is going to be y minus the negative 8, so y plus 8, is equal to negative 4 times the quantity x minus 2. From here, when we go to put this in slope-intercept form, I'm going to distribute the negative 4 in, which gives me y plus 8 equals negative 4x plus 8. Then I'm going to solve this for y, and I do so by subtracting the 8 over, which gives me y is equal to negative 4x. This would be plus 0, but again, we don't need to write plus 0. So I can transfer that down here, and the slope-intercept form is y equals negative 4x. From there, to get this in standard form, all I'll have to do is add the 4x over to each side, which gives me 4x plus y is equal to, these would cancel, so that's equal to 0, and that would be our standard form. Now we move on to talking about perpendicular lines. So we're going to start the same way where we're identifying the slope here. The original slope is negative 1. So when we go to find the perpendicular slope, we have to find the opposite reciprocal. So the opposite of a negative is a positive. I take the original 1 or 1 over 1 and flip that to give me still 1 over 1, which is 1. So now when I write the point slope form, I've got y minus a negative 2, so y plus 2 is equal to my m value is getting plugged in here, times the quantity x minus 5. Now you really could write this as y plus 2 is equal to x minus 5. That 1 does not necessarily need to be here, but I'm going to leave it like this for this example. Now as I move from point slope form into slope intercept form, I will go ahead and distribute that 1, which just gives me y plus 2 is equal to x minus 5, or you can think of just dropping that 1. From here, my goal is to get y by itself. So I still have to subtract that 2 on each side, and that's going to give me y is equal to x minus 7, which is our line here. Finally, when we move this into standard form, we want to bring the x over to the left side. So I'll subtract the x over. I get negative x plus y is equal to negative 7. Once again, I need to get rid of the negative that's associated with that x, so I'll multiply the whole thing through by negative 1. Which gives me x minus y is equal to positive 7. And for one more with the equation of a perpendicular line, we start with the slope of 2/3. So the perpendicular slope would then be negative 3/2. For the point slope form, we'll start with y minus a negative 1. So that's going to turn into y plus 1 is equal to the slope that we just found, so negative 3/2 times the quantity x minus a negative 4, which is again going to switch to x plus 4. We'll take that point slope form and change that into slope intercept form. We do so by solving for y. So I have a few options here. I can distribute the negative 3/2 in, or what I did here is I multiplied by 2 to get rid of this 2 here, giving me 2y plus 2 is equal to negative 3 times the quantity x plus 4. From there I distributed negative 3 in, giving me 2y plus 2 is equal to negative 3x minus 12. From there, I'm still trying to get y by itself, so I'm going to subtract the 2 over. That gives me 2y is equal to negative 3x minus 14. I'll divide everything through by 2, and my slope-intercept form turns into y is equal to negative 3/2 x minus 7. Then from there, when we go to put this into standard form, we take what we just got, and here we have to get our x value to be an integer. So we cannot have this fraction here. So what we'll do is start by multiplying the entire equation by 2. That's going to give me 2y is equal to negative 3x minus 14. From there, I can add that negative 3x over to each side, which then gives me 3x plus 2y is equal to negative 14. And for tonight's homework, there are 4 different topics that you're going to look at in Delta Math.